friends, this is Mrs. McBride coming to you straight from my kitchen table. The focus of the week today is that we are going to be doing circuits. But first, a quick joke for you. What did the bumblebee say to his wife? Honey, you're beautiful. All right, before we get started, I would recommend you having a blank sheet of paper. You might want to draw some stuff that's down here. We're going to focus on two different types of circuits. The first one is called series, and the second one is called parallel. Now, a circuit is putting a bunch of different electrical or circuit components in a loop. Okay, think if you've ever been at the gym and you've done circuit training, okay, where you've done this exercise, then this one, and you sort of come back to where you started. Same idea. Okay, you might be wondering, these things that we're drawing today, do these need to go on your green sheet? The answer is no. Don't worry about it. Okay. All right, so the first thing we're going to do is we're going to draw these different circuit components, and then I'm going to show you how that we can make them into both series and parallel circuits. Okay, this is one of these things that it seems complicated when we first start, but as we get into it, it should be pretty easy. All right, here we go. The first one is a cell. Now, a cell looks like this. So here's my wire, and then it has a short side and a longer side, and then another piece of wire. By convention, the long side is always the positive side, and the short side is always the negative side. And current is always going to flow from positive to negative. Okay, we'll do this a couple of times when we're doing our circuit drawing. Now, you probably learned about voltaic cells when you were in chemistry. A battery is just a combination of multiple cells put together. So we have a short and then a long, and then another short, and then a long, and then a wire. Okay. You'll see this used more than a cell, but just in case you see that what it looks like, I wanted to show you. Now, the light bulb is my favorite because I think it looks like the top of one of those Hostess cupcakes, sort of a circle with a little frosting drawn in there. Wire is the easiest one because it looks just like that, a straight piece of wire. Okay, now a switch looks like this. And what you see is that a switch is always drawn as open, because if a switch was drawn as closed, then it would just look like a wire. So whenever you're drawing a switch, it always looks like that, whether it's open or closed. Okay. The most common thing that we'll probably draw is called the resistor. And this looks like this little jagged line. It doesn't matter how many jagged lines you put here. You'll see I do a bunch of different ways, but that's what it looks like. And remember, a resistor is an electrical current that you find in most electronics that slows down the flow of current. You can also have what's called a variable resistor. And a variable resistor is drawn like this. It has an arrow on top, and that's because you can change the resistance. This was used a lot kind of in the olden days. We don't use this as much anymore. We have newer types of electronics. All right, we also have a voltmeter, which looks like this. Now, I want to write a couple of notes down about the voltmeter. Is that the voltmeter measures the voltage, okay? And I always say that this is a hugger, okay? Meaning that it likes to wrap its arms around whatever it's measuring, okay? And I'll explain that further in just a second. This is the ammeter, and it measures current, okay? And it likes to be in the circuit, okay? Meaning that if you were gonna measure the flow of current, the easiest way to do so would be as if you jumped right into the river, right? You could feel how the current flows past you, right? So the ammeter needs to be in the circuit. It's hard to sort of look on the side of a river and see how current is flowing. So we're always gonna make sure we put the ammeter in the circuit, okay? I wanted to talk about one other thing here, and that, I'm sorry that it's not on here, that would be the capacitor. Okay, a capacitor, and that just looks like two parallel plates. Okay, now here's where I'd like you to grab that paper that you had. All right, So what I want to do here is let's draw a few circuits. So the very most basic circuit would be a battery, and then one resistor. Now you'll notice that I always draw my circuits sort of as squares or rectangles. Could you draw them as circles, sort of like this? It's not wrong, but I just think you won't see that usually. You'll see them more like this. Now, does it matter if the resistor is here, or the resistor is here, or the resistor is here? Nope, it doesn't matter, okay? Now, when you're drawing this, remember I talked about the voltmeter being a hugger. Okay, so if we wanted to measure the voltage of the resistor, see how the voltmeter kind of like sticks its arms out and hugs that resistor? Okay, and similarly, the ammeter would have to go right in the middle of the circuit. Okay, so it might look something like this. Now you can do different circuits in different ways. Remember I said we can have something that is called a series circuit. Now a series circuit means all in a row. Okay? So if you have a series circuit, okay, here's my battery, here's my first resistor, here's my second resistor, here's my third resistor, okay? We said the long side is the positive, the short side is the negative. We would see that current would flow in this direction and it would have to go through all of these in a row, okay? If I wanted to measure the voltage of this, I could go ahead and put a voltmeter here. If I wanted to measure the current, I could put an ammeter here. Okay, well, let's say, for example, you wanted to draw now a series circuit where they're all in a row. And let's say you wanted a light bulb, a variable resistor, and another light bulb, and a battery. Okay, pause the video for a second and draw this. If not, go with me. I always start with the battery. Why? I don't know. There's my variable resistor. Okay, check. Let's do a regular resistor. Here's another light bulb. Okay, and as current is leaving from here, it goes through each one of these and back to the start. Okay, in a nice complete circuit. All right. What happens if I wanted to get crazy and I wanted to put in 3 light bulbs and 3 resistors and a battery and a voltmeter and an ammeter? Okay, pause the video and draw this, and then let me know what you find out. Maybe you drew something that looks like this. All right, the next type of circuit is called parallel. Okay, and this means multiple paths. Oh my goodness, let me rearrange here. Okay, in a parallel circuit, that means that it doesn't have to go all in a row, that you sort of have some choice. I equate this with like choosing the shortest line at Wegmans. Okay, so here's one resistor, and there's another resistor, and there's another resistor. Okay, so here's you. You're coming from the positive side of the battery, and you're saying to yourself, do I want to go down lane 1? Lane 2, or lane 3. So each individual electron sort of has to make a choice. So some of them will go down this way. Some of them will go down the middle branch, and some of them will go down the far branch. Now, if you're at Wegmans, what impacts the decision that you make about which line you choose? Well, you always pick the shortest line, right? Well, current is lazy, so it always takes the path of least resistance. So it's always going to choose to take the path of least resistance. For example, if this resistor is 10 ohms, and this one is 20 ohms, and this one is 30 ohms, you'll find that most people, most electrons, will go down the path of least resistance. So this one will have the highest current. How about this one? Will anybody go down the path of more resistance? Yeah, just like in life, there are people that will choose the harder path, and the same thing is true with electrons, but just not as many. Will people or electrons go down this path? Yes. Okay, but just not as many. Now, a common mistake I see when people are first starting is they want to put a couple of things on the same branch. Do you see how there's 2 resistors on this branch? That is a no-no. We're not there yet. That's called a combination circuit. So right now, each thing has to go on its own branch, with the exception, okay, of the ammeter, and we'll talk about that. Okay, so let's say, for example, I wanted to do 3 light bulbs and a battery in parallel. So pause the video and let's see what you got. Hopefully you drew something that looks like this. Okay, now what if I wanted to add a voltmeter and an ammeter? Well, a voltmeter, remember, that's a hugger, so it's going to hug this particular one. It sticks its arms out and hugs around it. Now what about an ammeter? Okay, if I put the ammeter here, it will measure the amount of current that goes down this branch, or the number of electrons. If I put the ammeter here, it will measure the current in this branch. What if I wanted to measure the total current? Okay, well, where is everybody together before they've picked their checkout line? They're leaving here, okay, and then someone could go down here, here, and here. Okay, so your ammeter, if you want it to measure total current, either has to go up here or down here. Hopefully that makes sense. Okay, so here's your ammeter, could go there, or it also could kind of go here. Okay, hopefully that makes sense. I will talk to you soon. Bye, friends.